Hi again, it's Pierre. It's a pretty lengthy series. Just hope you're not getting bored. This is some kind of a project that involves like many techniques or many different ways of making things. Just trying to show how each parts are made, and the different let's say skills involved, or like working different materials, working with different toolings and adjustments and things like that. So I find that's an interesting project. Plus, I mean, I'm going to enjoy a lot having the crane and not having you see the back of my head, or bumping the tripod, or trying to share the space with it's cameras are they're in the way lots of times. I mean, you never know how to set it up or hold it. So I think that should be a nice way to overhang a camera over the work, and keeping the tripod far from the machinery and things like that. That'd be a big improvement as far as I'm concerned. Though I hope it can help other people to improve their working conditions with the cameras around. There was Mike from Blue Hands Video that was asking about these V blocks with the holder, the holders on top. Let me show you. This is especially for Mike from Blue Hands Video. You were wondering about my V blocks with the holders on top of that. So that's a 4 inch by 4 inch by 3 inches. That's a nice big block, and it's easy to set up. You just slip in this part there, put it there, and you don't have to totally remove the screws to get your things going. Comes as a pair in a box. That's what I got, but the numbers on them, I've tried to see what it would correspond to. I'm not too sure. This is what it is. It doesn't correspond to Shars or anything like that, but I've looked in the Shars catalog, which is here. I think it's a 2012 catalog, but you got those blocks here. The dimensions, the one I have looks like this one here, which for 1992 a 2012 catalog is just like $115 for a pair of those. They look like very similar to what I got, so it's probably the same factory making them. So if it helps, like I say, we've been making pretty good progress on the camera, let's say crane, or some can call it the jib too. Don't miss the end of this 7 part B. I'm showing a preview of how we're doing so far. Let's say the assemble pivot in the middle, and show how it works, and so that's going to be some kind of a up-to-date preview of a partially functional part. And as soon as this video is on the tube, I'll be working on the rest of the what's left to do, and we'll keep you updated. First thing we want to do with this is make those two. I got the 2 bars like together in there, make them even and flat, and using I think it's an inch and a half carbide cutter with three inserts in there, running about 1600 RPMs. We go just manual to see if it goes good, and after that might switch in the this is automatic advance. Got about 100,000 depth of cut. Spilling the chips all over the shop. Okay. I'll get it up about maybe 1,000 or two, just to give it some kind of a few thousand, just to give it a finish cutting. There we go. Very light cut. Automatic advance. It's going to make a very nice finish. Okay. What we're going to do now, we're going to reverse this and lift up a little bit and make the other side same thing. I have to deburr a little bit out. I'm back in about 10 seconds, maybe, you know, like you say, movie magic. One tool I use to I'm just use, but I like a lot to deburr these long strips like that. I can do it with a file, but the best tool I find is a little that's a little Noga, very simple tool. It's going very good. Just one stripe in each side, each direction. You have to be well well supported. It does a better but very smooth first or second second go at it. One direction, the other one, sometimes you just hold it like you peel a potato. I know I peel potatoes at home sometimes. That's one method that goes pretty good. There you go. Makes a nice burr-free cut, and that's it. Okay, same treatment for the other side. Same speed, everything. I'm gonna make it 1.6 inches. Same speed. Locking the quill. Automatic advance. Small cut like that should be roughing and finishing cut at the same time. Okay, second side's done. We'll do some deburring. I guess you know why it's done. Okay, this step, we're making the ends even. First end, I'm using a 1-inch high-speed cutter. I also have two parts on top of each other. They've been faced together and sided, evenly sided together, but even there, you never know if it's really like perfectly even, and if they're not even in a vise, just like in this situation, there's one that might move or two might move. You never know what's going to happen. But what I'm doing, I'm using a piece of sandpaper that I just put between the parts and the vise. That will secure them. You have to be sure in advance that they're within a few, like 1 or 2 thousandths, because otherwise you might run into trouble. A piece of cardboard can do too, but usually the situation where you add like more than one part in a vise, you're at risk. So be aware of that. Let's face this. I want to maybe have a chance of doing a nice knurled acid brush. Still find that fun though. I'll probably find it fun when it happens to me too. I'm running about 800 RPMs. It's not a very heavy cut. It's just enough to make the end even. Okay, going past, I'm gonna make just a very light cut, locking the table in the reverse direction. This that doesn't have a lead screw, a ball screw in the mechanism of this milling machine, but it's pretty heavy and stable. There we go. That's gonna make a nice finish on one end. It's only a matter of a few thousandths of an inch. There we go. Okay, we'll turn this around, measure, make the other end. This part is going to be 7 inches and a quarter. Always, like, you see better the little piece of sandpaper I had there, and it really like secures the part. If you make some parts and you put, you know, like you put so much time to get into precision that's not needed, then it's really a waste of time. Like and not going to show, besides you just knowing in your head, and say it's got no useful purpose, no the time's completely lost. You can just do something else instead of that. But okay, let's go. 800 RPMs. I'm gonna make it low faster, like 1,000. Grease it up a little bit. Always the same 2 fluted end mill. I'm relying on a visual mark to get the okay. We're having a few thousandths for finishing. We're going to go back climbing. I lock the table because when the cuts are bigger and this, you know, like it shows that. Okay, that should be pretty close. Lock the table again. A little bit of climb milling. I'd say we're right on target. Okay, that's good. And you never go check with your fingers till the machine is stopped. Scary thought. Okay, now our parts are the length and the sides are even. Some deburring again, and we'll start marking. We'll start marking on top of each. You know, it's going to be in there a mirror. The measurements are going to be mirrored from one part to the other one. Both going to be the same, except maybe 1 or 2 holes. But we'll just do the markings and we'll proceed. Okay, project is going along pretty good. We're doing the side parts that will hold the collets and the bar in this step, and the drawing for this is 1 piece of aluminum. It's 3/8 of an inch thick. It's 7 inches and oh boy, anyway, 7 inches and something long, and it's gonna have holes that are dug 100,000 deep in there to act as, you know, to put a bushing in the bottom of that on each side, and also allow the other bushings to use the side there as a, you know, kind of a bearing. It's nothing that's going to work like constant revolution or something, so that will be like not very much solicited, but it'll be fine. And one of the difficulties to, let's say you have a center hole in there, and make the bottom of this very flat. I mean, you have a CNC machine that's you know, so easy. You just have to put in there, program, dipped up, and start cycle. And but this is done with manual methods. Everything's done with manual methods. I don't have room, or I don't have fundings for CNC stuff here, so that's what I'm doing. And I like having the handles in the hands and doing my own, taking the things in my own hands and controlling the machine myself. That's fun. Okay, so making a bottom square bottom hole in there is not exactly the simplest thing, but as we go I'll explain, and we'll just like start doing, and let's go for it. Okay, the parts on the machine. This is the aluminum part. It's 7 1/4. That's what I was missing before. 7 1/4 inches long, and we'll make you closer. I think having a good seat is always a privilege. Okay, because I'm gonna have to move a little bit. Now the parts in the machine, and we'll start positioning, making all the 1/4 inch holes. We'll start after that making the flat bottom holes, and adjust with the boring head. We'll adjust the surrounding of the hole, because I need a little bit bigger than what my boring mill will eventually do. Okay, first hole, we're 1 1/4 from the edge there. Since I have more than one piece to do, I just put myself a little reminder right there, and we'll make all the holes, the 1/4 inch holes, complete, and after that we'll do the boring and the reaming. The holes have to be pretty well in line, because we're boring on both sides, and they have, the bores will have to be matching close enough to to be like really in front of each other. Okay, let's go for starting to make the holes. Just we're center drilling because we need precision a little bit more here, and it's going to be a 1/4 inch hole. Sorry. Okay. There we go. This is the first one, and we'll get to the other ones. Okay, second hole. I will do some peg drilling, but I'm not really getting the bit too much out of the hole, because if you put it back in there, aluminum is not as bad, but steel, you will sometimes just squinch a piece of metal between the edge and the bottom of the hole, and then sometimes I will just, mostly with carbide, you'll kill your carbide piece. Okay, we'll go for the two last holding holes. These ones are 6 inches and 8/40. This has to be like, oops, unlock the table, it'll be better. These have to be like, not maybe as precise as the other ones, but within a few thou. It's easy to do. And also, we're working from the center line. They're 800,000 apart, so I'll move 400,000 in one direction, 400,000 in the other direction. So that's make them symmetrical to the axis. That will allow also better symmetry with these two holes, because you want to make sure that everything registers. Okay, and center drill, it's always better. we use the brake. Oops. Make sure your drill is going straight. Okay. I'm having problems here. Okay, that's good. Okay, same thing. 400 on the other side. Oops, 400 and... oh, half a tenth, not bad. When I move like that, you know, depending upon the required degree of precision, I will, mostly for drilling, you can allow easily half a tenth, and it's, you know, not going to be noticed anywhere. Okay. There we go. This is done. Now we're ready for the first boring operation. Okay, something practical I've got here. I've got a few holders, so sometimes I'm leaving tools in the holder. So all I have to do is go back and change it. And you know, power draw is I like that. So let's go and find the positions and drill that. We're ready for the first hole. This particular tool, it's got a special geometry which will allow you to dig, you know, a flat hole from about no center drilling or anything like that. I'll show you in detail after that what, you know, what makes it possible, and I think you'll find that interesting. Now let's go. We're going to calibrate, make a 0, and I'm going down exactly 100,000 you know, of it, 100,000ths of an inch down. We'll get the machine down to about 900 RPMs, and it's going to be squeaky a little bit. Well, you'll be able to put your sound down low a bit whenever. Okay, hope you see good. No, not in front. Perfect. Okay, we're touching exactly on the spot. $37,000. Yeah, I know it's noisy. Okay, we're almost there. That's it. And we'll do a little control. Make sure that we're at the right depth. We'll assume that we're right there, so we'll position for the first hole. 250 in the 10th. That's going to be perfect. Now let's just give it a little little control here. Oops. Okay, we're over by 2000s, which is very reasonable. I buy that. And we're in for the second hole. Same speed again. Everything locked. Table, all axes, and let's go. We're about to touch. And 3, 2, 1, perfect. Flip the part and go for the other side now. Oh boy, that's not exactly clean. Okay. A little bit of pressure down there. Make sure we're sitting down by checking the spacers, and another one goes in there. So turn down your volume. It's gonna get noisy. Another few thousands. That's it. We're going in. Another 100,000. $95,000, 100,000. Okay, moving to next position for. Okay, we're within 1/10. That's excellent. I buy that anytime. Okay, another dig. Okay, these holes are made. Now we're going for the boring head. Not that boring. Maybe one tip that everyone can benefit from, it's when you untie from collets or whatever, you untie tools, always drop a rag underneath. First purpose is to catch the tool if it will release from the collet, which this one won't. And second thing is to grab the tool, mostly milling cutters, which are very sharp and could injure you. So that's one little trick in between the operations. Okay, as promised, I'll give you a few images of that tool I'm using to go down straight and make a flat bottom on a manual tool. So it's a Valinite tool. It's I don't know if you can see the number here. It's a Valinite tool. I'll try to make it so you can see. If you stop the machine, there are the numbers. It's even made in USA. And if you look at the end of this, you see that there's one part different from the other. The two cutters on this, the two inserts, are not exactly the same position as in the relationship with the center. This one is more outwards and this one is more inwards. So it means that I will rake a 1-inch hole in one shot by inserts that don't have, let's say, 1/2 inch of a width. And this tool, allowed me to make a very precise and very flat bottom hole. Now I have to enlarge a little bit. If I known a few of the details of now, I would have made a little bit different. I would have made my bushings my exactly 1 inch, so that would just be used directly with that. But I'm a little bit bigger, and I'm going to be using next step the boring head to do the enlargement. Okay, maybe you want a few details about the boring head too. It's a very good quality boring head. It's a Parlec, made in USA. The number is right there, and this is to hold the collet or the boring bar that's going to go in there. I'm using a pretty small boring bar, and this is good for a 5/8 boring bar. This one is I don't know, I think it's 3/8, but it's got a special adapter collet to go for smaller size boring bar like this one, and it will move from there to there. Will move like 5/8 of an inch. So you can start as almost as small as your insert is, and go to move it along 5/8 of an inch, depending upon what's there, geometry it is, the size of what you have as a tool here. You can even make a T-tool and adapt the boring bar further, like it's going to give you the necessary move on it. And the adjustment on this is every division is 1/1000 of an inch, and as far as diameter is concerned, you can go in between with the vernier scale here, which will give you the tenths, and that's that's very touchy, very precise, and you end up making holes like within the tenth kind of easily with this.